I'm Barbara Marshall. For those who don't know me, I'm the Media and Entertainment Segment Lead. So today's session, we're going to talk about multi-GPU use cases and how you can sniff out those opportunities, huge growing area, and who better to talk to than Rick from NVIDIA. So this is really good timing. IDC has just released their 2022 data. And again, I'm assuming everybody knows, but if not, IDC is kind of the recognized research organization that measures computer sales, and they also specifically measure workstation sales. So this data is 2022 full year data. And the orange section is what we would call media and entertainment. IDC calls it digital content creation, DCC. So what you can see in 2022 is that M&E accounted for 11% of global workstation sales. This is considerably less of the whole market than a few years ago. Kind of long-term average, M&E has been 15 to 18%. But the big section, engineering as IDC calls it, or what we would call AEC, and product design and manufacturing, that has had a kind of COVID, post-COVID, huge growth area. So we can show a bit of context here. On the left-hand side, you've got from 2008 to 2027 forecast. As I said, 2022 is actual. The orange line is M&E. You can see that M&E peaked in 2019, and then throughout COVID, we've had a bit of a dip. Over on the right-hand side, just taking three data points so that if you prefer numbers rather than graphs, you've got some numbers there. 2021 actual, M&E was 12%. This year, 2022, 11%. And the forecast for this year is also 11%. And just going into a little more detail, this is M&E only. Again, 2022 actuals. You can see that although this year we are taking a dip from last year, the 2023 figures forecast is actually about the same as 2018. So although we're all very well aware of the macroeconomic challenges that Alex was referencing earlier, and we have got headwinds against us as a whole, I think it's important to remember that M&E is still actually up at the 2018 levels. It's just that we had this sort of COVID blip, which really boosted the market. And then in 2024, things start turning, or are forecast to turn and start picking up again. Okay, so I said that we had some headwinds against us, but we've really got some positive forces affecting media and entertainment. And that is the rise of the game engine and alongside it the GPU, which are transforming media and entertainment workflows. So on the left-hand side of the graph, of this slide, you've got a representation of traditional media and entertainment workflows. You've got the games industry that favored, through necessity, interactivity and was willing to take a hit on visual fidelity. And you've got the film and TV industry where visual fidelity was everything, interactivity was not necessary, everything was about the best picture possible. And that's why, back in the day, games graphics were terrible, in my opinion. They were rubbish, because you had to choose one or the other, interactivity or visual fidelity. Now, today, in the new era of virtual production and real-time rendering, you don't need to choose. You can have both. That's why games graphics now are photorealistic. The cinematics, the gameplay, completely transformed than 30 years ago. Same with film. Still got the visual fidelity, but we're now able to produce film and TV in the game engine, or we should call it the real-time engine, and make real-time creative decisions on set. In-camera visual effects is a reality, no longer having to wait till post-production to do the visual effects. Today, we're going to be talking about the GPU that not only has really accelerated virtual production, but has also accelerated many other workflows in the M&E industry, enabling real-time rendering in multiple software applications, not just Unreal Engine or Unity. So from script to screen, from left to right, the traditional M&E production process is pretty linear. Pre-production, production, post-production, and then play out, publish, distribution. In more detail, we've kind of mapped some of the key software applications to each stage of production. On this slide, we're showing a traditional live-action production pipeline. And by live action, we mean you've got real people in a real environment, whether that's a set or on location. So a lot of the production is actually done with a camera shooting real people, traditionally. A lot of the work is then done in post-production. And the old saying, don't worry, we'll fix it in post, was not a joke. You can see there was a huge amount of work done in post-production to correct what was shot or not shot, to add visual effects, to add motion graphics, edit, et cetera, et cetera. On the other hand, a CG or computer graphics pipeline had a lot more going on. Well, all of it's done digitally, that's why it's computer graphics, or it could be a heavy visual effects workflow. What you've got here is a lot more happening in production and pre-production, and you can see Unreal Engine and Unity, the real-time engines, playing a big part in this CG pipeline. The point of virtual production is that those two slides, those two pipelines are being merged, and the lines between pre-production, production, and post-production are blurring. A lot of what used to be done in post-production is being brought forward into the process, earlier into the process, so into pre-production and production. A lot of the visual effects and creative decisions are being made during the production process. I am going to hand over to Rick Champagne.
All right, thank you everyone. Glad to be here, of course, talking about the next generation of NVIDIA GPU architecture, which is the Ada Gen. This is a really important moment in time for us together. Obviously, you know, there's a new gen of workstation, but it's also a new gen of GPU architecture. It's a new gen of CPU architecture, and all of these things happening in the same year is very rare, as you know. I think the last time was maybe 6 years ago. And so I'm really excited by this. I'm also excited by the fact that there's a 4 GPU system now. And that's because it's hard to imagine that you can actually take advantage of, you know, all this compute that's in one board, let alone 4. But I'm going to show you some ways that we actually do that. So it is an exciting time. The main things to know about the new Ada generation, so it's the RTX 6000 that's been announced, and you've probably seen that. We have the next generation of RTX, which is the next gen of RT cores for ray tracing. So not only do they have more cores, but they have more tasks that can be offloaded to them. So really getting a lot more out of ray tracing. There's also the next gen of Tensor cores. And so again, more cores, but more capability. And then when Tensor cores and RT cores come together, of course, there's another multiplier there, because most ray tracing or renderers take advantage of AI for doing things like denoising. So there's all of these accelerators. There's a lot more video encode and decode now. So rendering to video is much faster, but also one of the things that's been really important on decoding video for us is getting video into a GPU faster so that we can run AI tasks on it. So we've been focusing on decode, but now we have 3x video encode and decode engines. This is dedicated silicon, just like RT cores, tensor cores, and then there's NVENC or NVENC, some people call it, dedicated silicon for doing just encode decode. And we also added AV1. And so massive performance improvements across the board because of this. Of course, we also have a lot more programmable shader cores, like the CUDA cores that you're all familiar with. And so we're getting 2x graphics performance, we're getting 2 to 4x rendering performance, and particularly with real time and anything taking advantage of AI. And then all of this in the same power envelope as the previous gen, which is nuts, absolutely bananas. So this is a look. At the RTX 6000 versus the Ampere generation versus Quadro RTX 6000. And if we dial back to the last introduction of a new workstation, it actually predates even the Quadro RTX because we announced the RTX at SIGGRAPH in 2018. So we're talking about, since the last gen of workstation launch, massive, like completely different world now. So you can see 18,000 CUDA cores. That's also crazy. We have a lot more RT cores, tensor cores. The memory footprint now is 48 gigabytes of ECC memory, GDDR6, so super fast memory bandwidth on that. And then, of course, you can virtualize this. I talked about the encode, decode, and all in the same power envelope. And then the next gen of PCIe. So this is kind of what it looks like. If you compare the dark green bar at the bottom, what you're seeing there is the Quadro RTX 6000. We're getting double the performance over that. So, and then you see, of course, that's with graphics, and then the rendering, 3x performance, and then AI, 2x 1.8. In fact, with sparsity turned on, you can get up to 10x performance improvement over previous gen. And so looking at the chart on the right-hand side, what you're seeing there is that massive performance improvement all in the same power envelope. Pretty wild. And so we just skip by a slide, but I can speak to it. Basically, what we're talking about there is consumer graphics versus professional graphics. And so there are a lot of benefits. On this slide, I've added some benefits that are specific to workstations as well. There's whole system certification, not just the GPU. There's the 3 years parts service, labor warranty, all of that good stuff. Specific to the GPU, the airflow cooling design is different. The airflow is designed to go out the back of the workstation, as opposed to blowing inside. And it's an NVIDIA-only design. So there are consumer graphics that are, GeForce, for example, made by multiple different manufacturers. And not that there's anything wrong with that, but they design them differently. They may design them for a water-cooled case. They may design them for, different use cases. They may have 3 fans. They may have 1 fan. They all change the design of the board itself. So the graphics card, the GPU is the same, the graphics card changes, and that affects performance. And so when you see benchmarks come out, sometimes someone ran a benchmark for 2 hours and you see a game graphics performance is slightly better. Usually they're very similar. But over the course of a day, because of the airflow design, performance doesn't get throttled on professional graphics. That's really important to know, because if you're rendering overnight, you definitely don't want your graphics performance throttled. You also want that ECC memory because you don't want to come back in the morning after rendering for 8-12 hours and see errors in your render. So that ECC is super important. The software certifications, of course, we all know are really important, especially at the whole system design that we do with you. The GPU memory capacity is critical. As we move into AI, as we move into denser, heavier workloads, larger geometry, building worlds, if you're in game dev or if you're building worlds for LED walls for virtual production, you need all that GPU memory. You also need some headroom because people are doing multi-application workflows. And as each application gets launched and claims memory space and you load files, it starts to consume the GPU's memory. And if you don't have enough, you're going to throttle performance. In fact, with rendering, if your data set exceeds the memory capacity of the GPU, you basically slow down that GPU to the performance level of a CPU render. And we've seen 10x to 30x performance improvement. That's what you're losing by not having enough memory. So why would you do that? So that's why the 48 gigabyte memory capacity is critical to us. There's IT manageability, making sure everyone's on the same driver, doing that remotely and pushing all of that. There's all of the different system level stress testing. There's rack mounting a workstation and putting it in a data center that's certified. We test that. And because of the airflow design, that's critical. So there are lots of different use cases like that. System optimizer tools from you, of course, and all of the support, of course. So NVIDIA actually, our customers who are buying professional graphics can call us, and we have solution architects that will come and help them develop something from scratch, or they can report bugs and we'll fix them. So there's a lot of that kind of support that comes directly from us, but then of course the support that comes from HP for all of this. So there's a ton of benefits. We have an entire deck. It's an hour-long presentation that Alan Burgoyne does. And definitely, if you want to know more about consumer versus enterprise class, then go through that training. It's on our partner portal. In terms of RTX accelerated apps, there are over 110. This is the modest count, because this is not counting previous versions. This is not counting Maya 2021, 20, 19, 18. This is current apps. I know other vendors count everything they've ever done. This is current RTX accelerated apps. Why that is important is because you probably sometimes also come up across Macs. Apple has moved to new silicon. A lot of the applications on those Macs are still OpenGL. They haven't moved to Metal yet. And then they have to be tuned for Apple Silicon. So they're trying to get that changed, obviously, but they're still not there. And they're far behind, obviously. They're nowhere near where we are with RTX in terms of professional creative apps. So there's all of that, but then also 30 plus apps that are multi-GPU accelerated. So all of the renderers, a lot of the new AI stuff that's coming out, common tools that people use every day, like Unreal that you heard earlier. You can render the camera frustum for virtual production on one GPU, and you can render the rest of the LED wall that the camera never sees, but the actors do. And so you can render those on separate GPUs to maximize quality where it matters most. You can also do light baking multi-GPU, so move into this. So this is a company, the software is called Vanity AI. It's by a company by the name of Mars, which is monsters, aliens, robots, zombies, which is perfect in this industry. And they do visual effects, and you've seen their work in Game of Thrones, you've seen their work in Stranger Things, in Wednesday, in Ms. Marvel, in Marvel movies like Spider-Man, No Way Home. So they do a lot of visual effects work. They had a problem, which was budgets are constrained. You hear this all the time in M&E. Constrained budgets, timelines are insane, especially with television and the need for content there. And then, of course, the quality bar keeps rising. This is a true story. It's not just something that the marketing people are saying to you. This is real, and this was their problem. And so to do that, they needed some accelerators. They knew AI was this thing that could help them. And so they started looking at what are we doing a lot of? And aging, de-aging, and cosmetics was something that they were doing on every show. There are actors who have this in their contract that you need to take 3, 5, 10 years off of them if they're going to appear in a movie. And it's in their contract, for real. And so this is like digital cosmetics here. This is digital Botox. So you can see the number of things that you have to do. And the other thing is that they didn't want their faces replaced, because these actors are artists. And they want their performance to come through. And if you replace their face, their performance isn't the same. And so what Mars did was they wanted at least 80% of that performance, the original performance, to still be there. But they wanted to be able to add or remove 10 years on either side of a person. And so that's what they did, and they turned to AI to do that. And here's an example of what they're doing. So what you're seeing here is there's an actor. This is their software interface for it. And they have these sliders. And basically, they're just fine-tuning different parts of the face. They train the network on years of expertise in doing this. This takes them days to do manually. They train their network on all of that work, and now they took days to minutes. It's sliders, and you can see how amazing that is. Super fast, the actor is still there. It's not a face swap, performance is still there. Everything's intact. What's amazing about this is that this is 4 neural networks that they're using, that they put an interface over, and each of those networks can run on a separate GPU. So again, the reason they can go real time is because they use multi-GPU systems to do this kind of work. And so here's a reel of their work, and then I have one last video. So amazing work. They've already production tested this on 27 shows. They're getting a new Z workstation, multi-GPU, and we're going to be doing a case study with them. So we're really excited about that. And so I am at time, so I'm going to skip the last video, but AI is here, and there's so much coming.
So these are going to be in the deck that you'll be able to get these decks, these slides, and be able to go through these and make your own decisions about how to work with customers. But these next 3 slides kind of go together to piece together that puzzle about what people need. And this is stepping back from the very complex scenario that Matt just described. I'm going back to general media and entertainment workflows here. So this is a slide that you've seen probably in other presentations. I kind of tweaked it a little bit, moving some dots around for the way I feel that the machines play out. But that goes into this. So everybody always wants to know, well, what machine do I buy if I'm going to be doing this type of workflow? And I don't think it's the machine, because our machines are so highly configurable up and down, I don't think it's important to assign a machine to a workflow. I think you need to talk about what components you need, which components you need to spend your money on specifically. So that's why I came up with this kind of slide. So this is something that I came up with a few years ago. I actually had audio on here back then, but I took that off because we wanted to talk about virtual production now. So that's why I added the in-camera VFX line down the bottom. And you see I've got an assignment there of whether it's a most important component or a somewhat important component. And again, I just have this in here for you guys to refer to. And then again, taking those same suggestions and then applying them to the different models of machines we have for the G5 workstations. And I stuck the Z2 on there as well.
Okay, this slide is just some useful links. And the first link here is the Unreal Engine Virtual Production Hub. It's a brilliant resource. There's so much content on there. The diagram that Matt showed in his presentation is on that website. The documentation, recommendations, how to configure a machine, how to set up a virtual production studio, all up there. So really get familiar with that content. The second one is the NVIDIA Media and Entertainment website. Again, excellent resource, a lot of great content there. And then the third is, I mentioned earlier that we're working with the Entertainment Technology Center. Each year, they produce a short film using the latest cutting-edge technology. So they've got a lot of documentation. We're working with them on a white paper, and we're also working with them at NAB, SIGGRAPH, IBC to have a working virtual studio as part of our booth. And then the final, all these images, Worldwide Marketing have put together all the assets that relate to media and entertainment, and they're going to hyperlink them, so it'll make it easy for you to just find them. Thank you.